just to be out. So welcome, and you've got a fantastic day ahead of you. Now, we've had some really exciting talks. We've had panel discussions on apprenticeships, moving manufacturing forward, what we're doing right, what we're doing wrong, and what we can do going forward. And today, of course, the core theme of everything is Industry 4.0 and IIoT, Industrial Internet of Things. We've covered a lot, and we're going to cover quite a lot today. Of course, you've got all the exhibition halls, and I'll let you know when breaks are happening and everything. Let's welcome to the stage the Managing Director of FANUC UK, Tom Bouchier.
Thanks, Lindsay. Good morning, everybody, and thank you for attending our open house. There should hopefully be something for everybody within this building today. I'm very keen, and I've said it to a few people here today, this isn't a FANUC show. It is at FANUC. It has a lot of FANUC product here, but we're trying to answer the questions on the barriers to automation. What is stopping the UK being as productive and being as automated as lots of other European countries, worldwide countries? I mean, if you took at the robot numbers, the UK is about 20th in Europe on adoption of robots per 10,000 people. I mean, that's just Europe. It's a shocking figure, and we do need to get a lot higher. We need to produce. So there's 45 different exhibitors in this building today, which is why it isn't just a FANUC show. We want to have other people in here to answer the questions that you have that we can't answer. We're expert on CNCs and on robots and on our automation, but we're not necessarily experts on other machining, on applications, on other things, but there will be the people within this building that can answer these questions for you today. As Lindsay started it off, there is some fantastic speakers here today. It's all about Industry 4.0 or 5.0, wherever your head is on that one, and the IIoT. And we're lucky to be joined by a couple of fantastic speakers. With that, I think I will pass it over to Lindsay to introduce the first speaker, but thank you very much for coming, and I hope you have a great day.
Thank you. Right, okay, so a very popular part of the past few days has been the panel discussions. So the next one, we are going to be discussing the future of automation, artificial intelligence and connectivity to make UK manufacturers more efficient. And then afterwards, one of the panelists will come up and do a talk as well. So, right. Let's welcome on stage Konrad Grohs from FANUC, Julian Smith from Polestar, and Andy Jewell from InTouch. Thank you. Gentlemen, to kickstart really the panel discussion, if each of you could introduce yourselves, where you're from, and kind of what you're going to bring to the table.
Shall I start? Good morning. My name is Konrad Grohs. I am Director of IoT Business of FANUC Europe, and I have a pleasure to join this conference for already 2 days, and looking forward to our discussion.
UK.
Thanks, Konrad. I'm Julian Smith. I'm the Managing Director of Polestar. We're based in the UK, and hopefully I'll get a chance to speak to you later on.
Thank you. Good afternoon. Good morning still. Andy Jewell, InTouch monitoring and Spitfire ERP. Been in the business of promoting, selling the MES systems, shop floor data capture systems to manufacturing companies for the best part of about 33 years. And hopefully can get some good conversation going on that today.
So, Konrad, if you'd like to lead the conversation really and start and kind of describe where are we with regards to automation and AI?
Yeah, I am automation engineer, so I work also not 33 but 23 years in automation, and I see that we made a big progress, and the industry in UK and also Europe is going gradually forward, but there is always a space for more automation. And when you mention AI, it's very exciting part of the technology, and we are still yet to discover what AI can do. So the most frequent application of AI in industry is vision recognition of parts or quality inspection. but I think the best is yet to come. How do you think, Andy?
Yeah, actually, everything you said I tend to agree with. AI, I think, is still in its infancy. I think there's a way to go yet and I think people are still trying to understand about where and pretty much where it can be applied, but you're correct, vision systems seem to be the initial method of using AI to differentiate whether it's bad product from good product, whether it's in the back room in the exhibition, we've got the recycling center there with the robot picking and placing various products for obviously recycling requirements. But most people's vision of AI, I think, is putting on a mask and being able to walk around a factory and look at information, data, get results out. Not quite sure we're to that stage yet, but who says that that's not too far away? But yes, initially it's pretty much on its way. My big gripe, I think, historically has been we need to get better with the basics sometimes as well. Yeah. We still go around, I think, in many factories, many manufacturing facilities where we're still trying to collect and collate data in a very inefficient way. Dare I say, paper and pen sometimes still, and I think that has to change. Is changing, has changed over the years, but I think there's still a little bit of hesitancy to move and digitize factory floors and to do that more quickly.
And maybe AI will help that. I mean, you're right, with what we see through vision, you can do some really low-hanging fruit and get some real immediate benefits from that. But I think on the data side of AI, where we've got things like variability and environmental issues in our factories and through our production processes, AI being able to help with the predictability side of things, so we can figure out, actually, is this the right time and place to be building this, making this, processing this? Can we do it better? And spotting those, particularly things with environmental systems, where we've seen in the food and beverage industry, for example, where that is a big impact on when processing, making products. AI can do a lot of help with those data sets and finding the patterns where they can do things more optimally. A very, very basic example, but I think basic examples are good, is somebody told me in the bread industry, they would actually have tasters go in to the labs at various points in the process, and actually they had the capability to sense and smell and taste to be able to work out when the environmental conditions were optimal for bread production. Now, actually, you could do that with sensors, or you could have sensors then feeding information back from that environment, so you wouldn't need these people to go in. I don't like the idea of people sticking their tongues or hands into bread that I might actually be eating as well, so I'd rather have a machine do it.
And people are very subjective as well, whereas computers are quite methodical.
This is true.
I think the word is consistent. That's probably a good word there as well.
That's it.
Yeah, I agree with the data analytics is another space for AI, because our brain capabilities are the same like 1,000 years ago when we didn't have a mobile phone and computer, but we are in front of more and more data, and for people it's very difficult, especially manufacturing, to analyze all this data coming from all these machines and correlate the data between each other and find the conclusion. So AI definitely can help to analyze big data and help the human to take a right decision based on the consolidated, aggregated, calculated data.
Yeah, I think the issues that arise, I think we may turn it into a situation where we're just collecting data for data's sake. Yeah. Just we've got the ability to do it. Let's just collect vast amounts of data. Yeah. But the sadness of it all is that we're not doing much with that data to actually make improvements, help with our continuous improvement activities. Yeah. I think we need to get better at doing that, and there's technology there to assist with that. Yeah. Perhaps more better integration of industry with academia, I think, is quite an interesting topic that we discuss years in, years out. I think we need to get better across the UK, the globe, in terms of getting the academics working better with industry to bring it on stream quicker and to commercialise it and to make it into useful products rather than than people's thoughts and sort of pie in the sky stuff, possibly, blue sky thinking stuff, make it a reality. Sometimes we think too far ahead, and I think that's a big issue. Maybe it's a bit more grounded and small step processes, but bring academia and industry together, I think, is a big part of progressing a good AI solution. Possibly.
Well, we should be good at that in the UK, right? Because we do have those institutions and that those academic folks, to make that, to realise that for UK industry and making us more efficient. I mean, I'd like to see how do we. You touched on this with all of that data. Which bits of those are important? What do we need to keep? Right. What do we need to throw away? And actually, what do we need to store for later, which may be useful down the line? How do we triangulate those three requirements into deciding what's going to be useful in the future?
It's a bit like the 1,000 photos on my phone that probably about 1% that are really useful to me, and I'd like to look back, reproduce, put into a nice print on the wall kind of thing.
Which ones are to keep? Because I never look at the ones on my phone. My daughter, my daughter puts most of the photos on my phone, particularly because I've got a new iPhone, so she uses it more than I do. I'm sure some tools in that that'll be useful. I mean, what we do, by the way, we're not Polestar, the car maker, unfortunately. So we kind of handle the connectivity piece in this discussion. So key for us really is being able to do some of that processing, potentially the AI, the automation, and the connectivity at the edge, so we can make some of those decisions before the impacts of those actions and decisions end up somewhere else, whether it's in the cloud, whether it's in an ERP system, we're talking about this, whether it was an action that's then taken back to the machine or the robot. And that's the key piece in the jigsaw, really, from where we think UK manufacturers can become more efficient. And it's whether or not you leverage some of the benefits from those cloud applications and bring them to the factory floor, which is what you guys do. How can AI help with that? What are the bits where we can optimize the automation side of things? This is what FANUC are doing with the field platform, and bring that, and how do you scale that across your production facilities and sites? So you're not kind of replicating what you're doing from one place in another place without being aware of that. That's one of the key things a lot of our customers ask, is that they want to build that digital twin. They want to do it once. They don't want to have to repeat that. Which data and which of those sites are being optimal for producing one part of a product, which could technically be made somewhere else more efficiently. And it's having all of these three things working together to do that.
Could you tell us, and please, if you've got any questions, please put your hands up, because we do have some microphones for you. Could you tell us about maybe some success stories or applications that you're working on at the moment, so it can kind of open our eyes to different routes that maybe some audience members could consider in their companies?
So we've done a couple of factory projects in the last 2 years. One of them is a greenfield site, one of them is a brownfield site. The brownfield site was where we retrofitted new connectivity into the site so that we could do some IoT type work at the end of each production line. There were sort of 30 at this particular site. And there's a proof of value really was, can we then take that data directly, push it into the cloud in a safe and secure way? So it didn't, you could get some real-time benefits, and then the customer could start taking those benefits to their other production facilities where they had an insight that something wasn't working optimally, and build that model where they could then make the changes, bring that other factory online using the same end-of-line connectivity, and start optimizing those processes between those two facilities. They were flying ingredients from the US to China, I think, and that gets quite expensive, as you can imagine. So they were trying to find ways, but they know there are better ways to do it, but they don't have the insights into what's going on at the right levels in order to be able to do that right now. But it's just building that for the future.
Yeah. I always say if you can't measure it, you can't improve it. So that's what all of that data is ultimately doing. I think we've got a question.
Good morning. Yeah.
Morning.
Neil Lamb for IMI PLC. And I was listening to what Andy was saying really about taking a few steps back. Having worked in this industry for a number of years, we all talk about, you know, stepping forward and what can we do next. But I'm getting the feeling that we've got lots of things being thrown around at the minute, IO Link, AI, and all this stuff. And when I talk to the simple guys on the shop floor, they say, well, what do I do with all this information? Where do I put it? So I've got a couple of questions really, or three. It's a three-prong. So I think what you were saying there, where are we currently using it in the simplest form? And forgive me, I'm a simple mechanical engineer. How can we use it better, basically? And what is it we need? What tools do we need to make it more accessible to be able to grow the understanding of it? Because you touched on it earlier about educating people, making people understand where we can use it. What do we think?
Who'd like to start that one off?
I think
can
it's one
start.
for you.
Sorry, were you putting your hand up?
Yeah.
Go on then.
I'm okay. So our experience is showing that the best way is to ask the customer what they are the pain points in their production and manufacturing, and then starting from their challenges, thinking what we can do, what kind of data, what kind of analytics, what kind of correlation between the data could be interesting to solve this challenge. If we start from the data, it doesn't bring so much effect because it's a very nice software installed on the nice computer, but nobody uses it because it's just nice to have. But coming from the problem of the customer and trying to find solution, this is the best way from our current experience. So when you ask about success stories, we have the best success stories when the company owner tells us what is his biggest challenge, and then we create a solution that he is using. And then whenever in the morning he opens his laptop, he doesn't open the Outlook or other application, but the SCADA software or IoT software, which tells him what are the major problems, where he should focus. The management attention is the most expensive asset of every company. So if the management can focus on the most important problems, then you have the biggest financial benefit. And this is our way. How do you think, Andy?
Yeah, I agree. I think it comes down to you've got to understand what your customer requirements are, what the pain points are, where the problems are, have a good understanding of that, which obviously takes time and effort and communication. But my philosophy on all of this is that there's systems in place already in many places, some more sophisticated than others, still a great many with very low sophistication. Look at the simple solutions to start with, look for modular solutions, look for things that you understand and can implement and realize the potential from it. So, you know, the simplicity of, and then it comes back down to, what are my machines doing? My machines are my, you know, make my money, make my profit, make my output. Are my machines running? Are they not running? If they are running, how well are they running? What are my scrap rates? Do I calculate them correctly and accurately? Am I in control of it? You know, we're leading up to this OEE figure here, but there's a lot more involved in that. Am I scheduling correctly? Am I, you know, sequencing my products in a correct sequence to minimize downtime with changeovers, that kind of thing? That can relate to CNC machining, injection molding, food industry, you know, clean down. How quick, you know, am I monitoring my clean downs and prep work so my materials are arriving at the machines at the same time so I can actually make the production? There's no point having, you know, if I have to dry material to make a product, for instance, in the molding industry, no point having the best med principle going if the material that you want takes 4 hours to dry and somebody last minute thinks, oops, forgotten to do that. You've just done a tool change in an hour, but you've got another 3 hours wait for your material to dry off. You know, simple stuff, and you can get that from simple systems, simple digital output systems like the iLink is good for that kind of stuff. From FANUC, we do that with InTouch. There's probably about another 5, 6, 7, 8 systems in the molding industry. You've got systems in the metal cutting, food industry that do similar things. There's some good technology out there and it's actually now cloud technology, so the cost of entering that arena now is at a very low level. You don't have to spend thousands and thousands historically, as you used to do, on servers and Microsoft and everything else that goes with it. Now it's a cloud-based system, very little IT infrastructure required, and the software is on a subscription, so you can switch it on, switch it off if it doesn't quite produce or do what you want it to do. That leads into something else actually, which is really change management and people and getting people to buy into it. Well, that's we can come back next week for that discussion.
Can I just ask as well, what pain, I used to do a mechanical engineer, but do you have any pain points that you actually want to bring up? Because I think...
Not particularly. It's more, my view really is how is it more approachable for everybody? I'd feel that everybody is sort of talking about lots of technology, but what does it mean to the man on the shop floor? How can he actually get access to it and use it? I've got this vision of, I've got loads of information coming in. What I need a black box that tells me your machine's going to fall over, or you're approaching the point where your actuators that you're using are about coming to the end of their life. How does that spew that information out? Have we got that? Is that around?
Simple smart TVs with nice, simple to read information for the people that are reading it. So the operator will want specific information that's related to what they do in an 8-hour shift, 12-hour shift. You know, how many parts, how many production they made, what's good, what's bad. If there are some bad production, some simple method of indicating that to the technology so that updates real time and updates your stock control. You know, because if I'm making a bad part, my material consumption now has just gone up without me realizing it possibly. All these things, it's simplicity. It's looking at what the different people in the organization need in terms of information to make their life easier, better, faster, more exciting even as well, which sort of leads into getting young people into the industry.
And that was the other point of my question was how do we
get the young people?
How do we get young people into it? How do we get people? Is it a taught science now? Are people learning this at, I don't know, A-level or in university?
Information back through the smartphone. This data we're collecting, sift it out, sort it, divert it to the people that can make use of the information that's easy to understand, depending on, not always easy to understand. You've got the technical people that want, it can be quite complicated data, but they'll be able to interpret that because of their level. The operators on the machines just want to know they're doing a nice job sometimes, that they're making their 1,000 parts a day or whatever it is they're being asked to do, and that if there are issues that they've got documentation there, digitized documentation they can look at through their smartphone or their nice little easy tablet on the machining center. It's about communication, and they're real-time communication as well to obviously reduce costs. I think
it's like we were talking about just before we came on actually. Simplicity, what you're talking about here, is really, really ultra important. I was talking with Konrad last night about the factory owner, manager being able to look at something that's come up overnight and then go down to the plant floor in the morning, find out more about it. Just simple interaction like that. Or we were looking at tracking kegs at one point and lots of complexities around RFID. We couldn't really figure out how to do it optimally. So somebody said, why not just strap a mobile phone to it and see if it works? And we just thought, bloody hell, it does work. Yeah, okay, we've proved that works. Let's find out how we can then miniaturize that and make it a little bit more rugged and robust. But it just got that idea off the ground, or got that conversation off the ground enough to then take it forwards. So the simplicity bit really does need to be,
it's a key element.
Down to earth.
Bring the people along with the technology, I think, rather than...
Yeah, I think
it's
simplicity and fitting the purpose. So if the people will see the value in the information, they will use it. And if they will not see the value, they will not use it. So the simplicity and fitting the purpose, I think, is a key.
Yeah, it's interesting you say that. We were just having a conversation this morning about trying to track stuff around a big organisation, like pieces of kit that you're using. And somebody said you can buy these little Apple chips, which is basically just an identity. It's like a tracker. It's like Find My Friends.
Yeah,
you can put that on.
Got one on my keys.
Yeah.
Konrad, what you were saying about solution and finding the pain points and that sort of thing, I fully agree with that, and it's exactly what we do. We deep dive, you try and understand what the process is, you understand what the pain points are, and then you try and pull out a solution that might well adhere it. But there does come a point where you have to have something to demonstrate that says, because this guy might not know he has a pain, but this might do this for you. So you've got to have some building block, that product, if you like, or solutions that are there available for the smaller man, if you like, in a jobbing shop or something like that. We're not talking about JLR or whatever. Somebody, because they want to start learning it as well, and they're the guys that are going to expand into the next big companies. So there is a degree of having something that you can take and say as an example, rather than just everything being a custom solution. Because custom solutions, as soon as you say custom solutions, everybody goes, well, that's got at least 4 noughts behind it, So I think there is the need to push that as well.
Yeah, the sharing good practices, lessons learned is a key. So when we see our experience with SMEs, it's typically we need to give them information based on which they can take the action. So just the most beautiful software which nobody will use and take the action is not really bringing financial benefits. So when we have an experience with SMEs, we see that the best financial benefits are experienced by the users who are taking the action. It's a very trivial, but it's not really obvious that users are taking the actions. If the software will indicate, for example, that the machine will break in 3 days, but they will do nothing for 3 days, it will break. The software is fantastic, it's working, but there is no benefit. So benefits is only from the user taking the action. It's the key.
And I think that's one of the key points. There's a sort of a saying that goes around a lot of manufacturing plants is that we won't fix it until it breaks. I think we need to change that.
I think that's quite common.
Change that thought process. What's the cost?
We talked about that earlier.
What's the cost of something breaking? It's massive, isn't it? So
you prefer to fix it during a natural downtime rather than fix it during a period of mass production.
We've got another.
Anyway,
question
thank you guys.
Thank you.
We can talk more later.
Yeah, that's what it's all about. We've got another question.
So, Andy, you briefly touched on IT systems and infrastructure,
yes.
But I feel at the moment the conversation's only been in a localized manner, and it produces a simple model, the way you expand on automation. And as an automation integrator, I want to know what you guys are looking at to move up to that complexity model of where you're interconnected globally, and how you're protecting customers who want that simple solution, but how you guys are looking at doing the AI, the automation and the machine learning aspect of it. So how you guys expand into that different model.
I think that, if I understand you right, I think the question relates to how do we collect and collate data and then move it around more simplistically.
Yeah, well, the more, in a localized method, the model becomes in a simple way because you've got less users, but the more data you acquire, the more users are input into the system as an overall IT system for the automation to the customer who you sell your solution to. So if you have a solution, let's say in France, and a solution in America, if part of the problem happens in France, does it affect America? And how do you upscale your full AI learning capabilities and automation in a global model rather than just a localized model? Whilst making it excited to people who want to jump into automation.
That's a good question. It's more of a scaling factor in terms of the supply company, I think, is an issue there. We talked about SMEs earlier and enterprise and the differences. Enterprises can, spend a lot more money, have a lot more resource applied to resolve those kind of issues across global. Typically, enterprises are global, and then you go to the big systems, whether it's ERP systems from SAP or Infor or the top 6 type companies. But those say I suppose in a way, coming back to the conversation we had earlier, you're also trying to then apply that or give the option of that same capability and technology to the small companies as well, the SMEs. And there's companies out there that will meet the requirements at that level equally as much as there's companies out there that handle the enterprise organizations. Not saying that small companies can't handle enterprise applications, but it's a scaling factor essentially. It brings into account, you know, if I've got an application I'm implementing in Germany, for instance, as against an application or a similar application I'm running in Brazil, how do I now manage both projects simultaneously, bring them on board simultaneously, and then marry them up effectively so they're, you know, hopefully doing the same thing in the same place. What's interesting about that is, and I've worked in different countries with different products and the same product, and the interpretation is sometimes different, cultural differences, all this kind of thing do tend to play in that a little bit. But I think it's having a good infrastructure within your organisation to be able to manage. And it also comes back down to you, the customer, being able to have the right people with the right technical expertise to actually implement as well. That's a big factor in whether projects go well or not. In terms of movement of data, getting data from machinery, there's lots of new standards coming out now which hopefully will make the ability to collect a bit of information from a FANUC machine in Japan and be able to look at that and just, you know, do the same on a you know, maybe a moulding machine in China, for instance, and be able to pull that data together more simplistically. We've got standards like OPC UA now that are becoming more and more predominant. MT Connect in the in the machining industry, which actually does have an OPC UA connectivity as well. In the business, I tend to do a lot of work in the injection moulding industry, where FANUC are also active. You've got material handling systems, you've got the control systems on machines now. They're all becoming OPC UA connectable, which means that getting the data from this equipment should become easy and relatively straightforward. And it is becoming easier and relatively straightforward. The real key is what we then do with that data to actually make use of it and improve and, you know, make use of our continuous improvement programs and things like that, and improve productivity, improve profitability, which is the name of the game ultimately. I don't know if that's answered the question, but I'm going to...
I think what you were getting at is sharing data, aggregating data, pushing it into the supply chain, getting visibility on it with your suppliers. So you're being able to see...
It's absolutely all of it. There's the systems part of it, which is what Andy said is absolutely right, but then there's the consumer side and the deliverable side, which is the other side of it, which is it just becomes a lot more complicated very fast, and none of it at the moment is very well standardized, so it makes for very complex models rather than simple models joined together, so it's very hard to manage in a global aspect. So
yeah, there's a model I saw a few years ago in Hanover called the Industrial Data Space model. Don't know if you've come across it. It's worth a look. It gives you patterns, let's say, for how you can exchange and share data in different ways, either directly from the source, from your plant or machine, or then potentially sell that data to somebody else in your supply chain, a partner, an integrator, somebody like that, and how you can then get some benefit to somebody else who you work with. It's all very conceptual, of course, and this is where we're at now. I mean, we're at that stage where we're just trying to find better ways of sharing it, doing something, actioning it, basically. And that's the key, really. And yeah, I think you mentioned AI might help with that.
AI and machine learning. I know you guys haven't used the keyword machine learning yet, but I think machine learning feeds into AI before AI can feed back around. So, yeah.
Yeah. I think you're right. I think the machine learning aspect is where the rubber meets the road for that. And I mean, I'm hoping these guys will solve that particular problem for us.
Yep, second that.
Yeah, if I may add something regarding data sharing and the collaboration between companies, it's the big topic is data governance and data ownership and who has access to what kind of data. In our business, what machines are doing is very often related to intellectual property of the customer. So this kind of information is not not public, and it's very important for customers to protect their own data. Also, even simple stuff like cycle time or how many products I produced can influence my business, because if my customers knows that I have a problem, that I have not enough orders, maybe they will negotiate better pricing. If my suppliers will know what I'm producing, they also can use their position. So data governance, accessibility to the data is a big topic, and especially in SMEs, they have a lot of reservations and concerns, but also big companies have. So yeah, it's good to share the data, but we have to share the data smartly and with all these implications and regarding data governance.
Yeah, I mean, one of the challenges at the moment is getting parts and anything that's got semiconductors into a customer. You know, we've been waiting 3 months for a particular part, 6 months. The vendors, these guys we're talking to, they're being very transparent with us, saying, look, everybody's got the same problem, you know? So being open in that respect, that works. That kind of works the same for everybody. It's going to be interesting to see what happens as production ramps up of semiconductors, and we're starting to see the hardware coming back and seeing some realistic timescales on those. Whether those channels will still be open, but maybe there's an opportunity there to keep those lines of communication open, really, because we're going to need to accelerate and escalate forwards now to recover from and retool the factories to do what we were doing before.
Not sure if it answered the specific questions. Hopefully you got some good stuff. Yeah, but we were floating around if you've got some really specific kind of... Absolutely. We're around.
Got another question for you.
There's another lady, I think.
Hi.
Hello.
If we just go back to the point that the gentleman made about what do we do with the data, I think maybe historically smaller companies haven't seen a necessity to have a dedicated automation engineer or team of automation engineers. And that really is what we need to sort of be the person who can gather that data and represent it in a useful way. And if we don't, I know we have the issue that we don't actually have that many automation engineers, but I think if we make it a sort of a necessity that every company needs someone whose job it is to solely do that, really, then if we sort of put that job out there, that's how we're going to create, those roles. I think people will fall into it.
Are you suggesting every company should have a digitization guru to basically...
what, sorry?
A guru for digitization to
I think we need
force
it, really.
the implementation of it?
Yeah, because I think...
Wholeheartedly agree with you.
I think, we've had sort of... You've always needed electrical engineers, you've always needed mechanical engineers, but
yes.
As we're moving forward, I think we've sort of lost the fact that we need automation engineers as like a third component, and everyone needs that, or it's not really an electrical person's in their realm quite so naturally, so it just sort of doesn't happen, automation, unless you have someone who's there sort of making it available to people, because no one really knows what it is they could do with it.
Yeah, I mean, it's joining the dots, isn't it? It's taking those outputs from that machine or that device and actually realizing what you can do with it, and telling other people in the organization, or them coming to you and championing it. I think, this is what the people over the road hopefully are being trained to do. Because, we need to go out to them and say, what can we do with this? And they need to join those dots for us.
I think it's imperative that we digitize the factory floor now, and partly the reason I say that is not just for efficiency drives, improvements, that kind of thing, cost downs, all the other great words that we tend to use to improve our profitability, but I think and I think you share this idea as well. I think most people do. We need to get more young people, millennials, that generation of people coming into manufacturing. Manufacturing has not always had had the right level, skill set level of people coming in. I think we need to make it more attractive, and to make it more attractive, we've got to have tools that they use every day in their daily lives that they will now want to implement in their work environment. And yes, the front office has a lot of that already, but I think where it will really help improve productivity and, you know, Great Britain, UK manufacturing is, and various other parts of the world is, and they're doing it as well, is getting digitisation down to the shop floor level.
We very much touched on that yesterday.
Did we? Sorry, I wasn't.
No.
I wasn't
You've
around,
hit the nail on the head.
I'm joining the dots.
You've added to the dot, and you absolutely have.
I was working backstage.
I think we've got another question.
Morning. Similar to what you've just said, and it's been brought up a couple of times now, there's a very big and needed push to get more young people into STEM and to get them to develop these skills. But in the interest of efficiency, is there something that manufacturers should be doing with people they already employ who perhaps are further through their career and didn't have digital skills to learn when they were 16, 17? How can we use them best to make sure that the entire workforce is trained up to use these novel technologies?
I think we have to come back to the simplicity. So we are really pushed by customers to make our products simple, easy to use because of not enough availability of labor and the engineers. The customers want us that the robot will be operated not by engineer but the not qualified person after 5 minutes of trainings. And the same is in the software. If you know, one of the most successful companies producing the mobile phones, the founder of the company, he simplified the product. So there is a very advanced technology behind, but the operator doesn't need a training, doesn't need manual, doesn't need anything. So simplicity is the key, that the technology must be advanced in the background, but has to be very simple on the user front. So I think this is the solution.
I think there's going to be a push to upskill. I think that the whole idea of this conference and exhibition and meeting is automation. If we don't already realise it, is the way forward in the developed world. You've got to have more robots, cobots, methods of collecting and collating and moving data around that basically make everybody more efficient to the point where they're not just doing one job, they're doing 2 or 3 jobs, and you know, maybe there's more spare time to go out and play golf and various other things that people want to do. But I think what that means is simplicity in building the technology is key, but also there's combined with that, there's the upskilling element where you will actually need to train people to do more technical type stuff or understand more technical type stuff, albeit try and make that as easy and as simple as possible. But that's the challenge, obviously, I think, a little bit. I don't know if you
touched on some interesting things there, actually. I think, actually, it's the customer as well coming to you and saying, can you do this better? Can you make this better? Is there a way of optimizing it? Can you get your people who know how to do this to think of better ways easier ways of doing it to get this product to us more quickly? And I think it's bringing those people into the process may well give the people in the organisation hopefully the desire to upskill themselves, not just the organisation they're working for, but their own career development plans and things like this. Because I think that's what, that direction, and I think that's what they were talking about yesterday, because they only got part of that conversation. But some of the people who came in from Amazon who were 27 years old apprentices, I thought that was absolutely brilliant. They're taking some of those things they've learned before they went there and hopefully taking some of the things that they've learned into Amazon and then potentially back out again into the smaller SMEs. So we can benefit from that, really. And again, I guess it's the consumer that's driving Amazon, really. That's where we're customizing our dog food so it's got those things in it that don't make our dogs sick. And that's driving it. And if we can take that back into our organisation and apply that to something else, then brilliant. I think that's a great idea.
Yeah, we have to get used to that. We will learn all our lives. Our parents could have one education, they could survive all their careers with this education and retire. But our kids will have to learn every 20 years because their jobs will be obsolete within 10, 20 years. They have to go back to school. and learn a new job, and then every 20 years we have to go back to school. So this is the future, that we have to upskill ourselves naturally because of technology and progress.
Yeah.
Absolutely, good point. I thought 20 years has been a bit optimistic. Yeah, that'd be good.
Any more questions? Yes, one at the front, brilliant. Well, can we just get a microphone just to the front, please? We've probably got about 3 or 4 minutes left, if that's so. No, we'll get it to you, don't worry.
Hiya.
Hello.
I'm Suneli, and I'm from IMI as well as Neil. So I just had a question. So one of the things that's been talked about a lot these days is around COP26 and net zero. And one of the key factors of that is that reducing the carbon footprint of the manufacturing industry. And I was wondering how AI and machine learning and connectivity could help in terms of helping manufacturers and factories or operations managers know what exactly they can do to reduce their carbon footprint.
Can I take that one?
Yeah, sure.
Okay, great. Good question. And it fits in with the theme of COP26. The key to that is first of all, to understand what we're using. All right. In many factories, there's a bill that comes in for the entire usage in the factory every month, and nobody knows where they're losing it in the environment. Okay, there's big machines, little machines. Everybody makes a noise about changing the LED lights in the office.
Yeah.
That's only 5% of the usage, all right?
Yeah.
The big users are the injection molding, the die casting, the bottle making, the food manufacturing, the cake making facilities in the factory floor. And how many people currently in all these factories are now measuring individually the usage on those devices?
No.
Sadly, I can probably say not many at the moment. But as the costs of fuel go up, as the levies go up, as the taxes go up, I guarantee there'll be a lot more people talking about monitoring the individual usage of their devices. A bit like what we do at home now. The home has already started it with the,
Nest.
The Nest. Yeah, I don't have one yet, oddly enough. But I will have soon. But the idea is that that same kind of understanding needs to apply to industry as well. And it's being forced a little bit by the governments of the day now in different parts of the world to obviously reduce and to understand what we're using, how much we're using, and then obviously to then look at how we can reduce that. You know, is there more efficient motors we can use? Is there, for instance, in the molding world, you can still have a machine with all its heater bands on with no work on it. Well, if I've got a system that tells me there's no job available for that, why can't it also tell me to automatically switch it off? All technically feasible. We just need to put the cost of fuel up a bit more to make it a bit more viable, I think. Yeah, it's getting there slowly. But the idea is to measure it, understand what the usage is, understand where we're using it, where we're losing it, and then how we can make improvements to reduce it and find better technology.
More at a machine level rather than a component level.
Yeah, down to machine level. For instance, you've got electric molding machines, you've got hydraulic molding machines. Which one's using the most? If it's the same kind of machine, does the same kind of thing. How much usage do we have on this? How much usage do we have on that for the different products we produce? Nobody's really doing real live analysis online, continuous, making the comparative studies and then deciding using empirical data, not guesswork, what we're actually doing and what we're going to do about it to resolve it. So in the future, do we buy more electric machines because we can run that machine at 1.3 kilowatts, I think it is, out on the shop floor there, an hour to make a production run, as against the one that's 20 kilowatts. Does that then feature in what, the purchase price and the long-term costs of running that machine, all the things that feed into CO2 emissions effectively?
Yeah, this could be a scale of a machine, of the production set, the production line. So your examples are also typical for our business, that, for example, robots could could be the robot work can be optimized to save the energy. So the robot maybe doesn't have to work so fast, but can save a lot of energy by moving more optimally. And also the robots or machines, they regenerate energy. When accelerating, they use the energy. When they accelerating, they give back energy. This technology are already existing with FANUC robots or machines with FANUC controls. And talking about the production line, your examples are also, I would like to add the example of very often on a production break during lunchtime, the machines are off, but the conveyors are still working empty. So this kind of situation can be addressed by data correlation with different machine learning, or even simple mathematical algorithms can be solved. So there is a big potential for software and for data analytics, but we need to know the purpose. We need to start from the purpose, and if the energy consumption reduction is the purpose, there will be a lot of applications. And actually, nowadays our customers are faced to the rapid energy cost increase, so they are talking about this topic more and more often, not only being responsible about environment, but also about their own wallets. This really motivates to customers to save energy everywhere.
Fantastic. We've got to come to a close there. Sorry, I'm going to be strict on timekeeping.
No.
However,
Sorry,
Konrad
later.
is late. You're doing a talk at 1:45,
Yeah,
aren't you?
also Julian will talk and Andy will talk.
We're back again, I think.
Oh, you're all. Oh, yes, of course, you are back again. You are.
We have one more, I think, as well.
Brilliant. Yes, you are. Okay, so we can continue discussions a little bit later on. But please, could we give Julian, Konrad, and Andy a massive round of applause?
Thank you.
Thank you very
Great
much.
questions.
Your timekeeping is perfect. Thank you, Lee. As Lee just said, any questions? It is time for lunch now, so many of you are probably ready for that. But we will be back later, and we'll be talking IIoT, and we'll be having another panel discussion for you to get involved in as well. So we'll see you back here at 1:45. Enjoy lunch. It's amazing.